Hello everyone. In this video, we are going to see single phase semiconverter. The single phase semiconverter is a one quadrant converter, which means the output voltage and current both are positive. The single phase semiconverter circuit consists of two SCRs and two diodes. The single phase semiconverter can be operated with R load, RL load, or RLE load. Now we are going to see the operation of the single phase semiconverter with R load. The circuit of the semiconverter is drawn here, which consists of two thyristors, two SCRs, and two diodes. And the input of the single phase semiconverter is a single phase AC voltage. The output of the converter is given to a load. The input AC voltage is given as Vs is equal to Vm sine omega t. We can name the devices as T1, T1, T2, and T2. And the output voltage is measured across the load. Output current is denoted as I0, and the input current is denoted as Is. Now this converter can be operated with V0 and I0, with both are positive. Since V0 and I0 both are positive, we will be able to get only the first quadrant of operation. That is, if we draw V0 and I0, if we draw the quadrant of operation against V0 and I0, we will get only the first quadrant of operation, the first quadrant of operation. That is why it is called as single quadrant converter. That is one quadrant converter. The diode, the thyristor T1 and diode T1, they are forward biased during the positive half cycle, and the thyristor T2 and T2, they are forward biased during the negative half cycle. Now we will see the operation with R load. From at alpha, we will trigger T1. Once we trigger T1 and D1, they will be in the on condition. And during that period, we can write the output voltage V0 as Vs. Then at pi, T1 is turned off. And after pi to pi plus alpha, there will not be any device conducting. So V0 will be 0. From pi plus alpha to 2 pi, T2. Now at pi plus alpha, T2 is triggered. So T2 and D2 will be in on condition. Hence V0 will follow minus Vs. From 2 pi to 2 pi plus alpha, no device will be in on condition. Hence, again, V0 will be equal to 0. Now we can draw the waveforms. We are going to draw the waveforms for the input voltage, the gate currents, output voltage, and output current. The first waveform is the input voltage, which is the sinusoidal voltage. So we are going to draw the sinusoidal voltage for 0 to 3 pi, that is 1.5 cycle. The peak value of the voltage is taken as Vm. Now we are going to draw the gate pulse or gate signal of the first thyristor T1. And the firing angle for T1 is alpha. At alpha, we are going to release the gate pulse to T1. Again, at 2 pi plus alpha, we will be releasing the gate pulse. to T1. Then for T2, we are going to take the signal, gate signal as IG2. We will be releasing the gate signal to T2 at pi plus alpha. Next, we are going to draw the output voltage waveform. So output voltage waveform can be drawn by taking the possibilities, that is from alpha to pi, T1 and T1 on condition, at which the output voltage follows the input voltage. The output voltage is equal to V naught, Vs. The output voltage is equal to Vs from alpha to pi. And from pi to pi plus alpha, no device is on, so output voltage is 0, which is drawn here. And from pi plus alpha to 2 pi, the voltage is equal to minus Vs. So this voltage is brought in the positive side. And 2 pi to 2 pi plus alpha, the output voltage is 0. Then from 2 pi plus alpha to 3 pi, output voltage is equal to Vs. This is the output voltage waveform. Then we can draw the output current waveform. Output current waveform will, the shape of the output current will be same as that of the output voltage because the load is R load, but the magnitude will be different. So the output current will be, the shape will be same as the shape of the output current will be same as that of the output voltage waveform, but its magnitude will be V naught by R. The magnitude, the peak value will be Vm by R. So the output current is drawn here. I naught is equal to V naught by R. The peak value of the I naught will be equal to Vm by R. All the waveforms are drawn against omega t axis. Now we are going to draw the input current, that is source current Is. The source current Is will be positive, will be equal to plus I naught whenever T1 and T1 are in the on condition, and it is equal to minus I naught when T2 and T2 are in the on condition. So this is the input, that is source current waveform. Now we can obtain the average voltage expression. V naught average can be written as 1 by 2 pi integration alpha to 2 pi plus alpha V naught to T omega t, which can be rewritten as 2 by 2 pi integration from alpha to pi plus alpha V naught d omega t, which is equal to 1 by pi integration alpha to pi plus alpha Vm sine alpha to pi. That is, we can split the integration into alpha to pi and pi to pi plus alpha. From alpha to pi, V naught is Vm sine omega t, and from pi to pi plus alpha, V naught is 0. So 1 by pi integration, we can take Vm outside. So integration of sine omega t will be integration of sine omega t omega t. So integration of sine omega t will be minus cos omega t. The limits are alpha to pi, and which can be substituted as, by substituting the limits, we get minus cos pi, minus of minus cos alpha, which is plus cos alpha, which is equal to Vm by pi. Minus cos pi is 1, so 1 plus cos alpha. This is the average output voltage. Now, we can change the V0 average by changing the alpha value from 0 to 180 degree. When alpha is equal to 0, V0 average will be equal to 2 Vm by pi. When alpha is equal to 180 degree, V0 average will be 0. Now we can find the RMS output voltage. V0 RMS can be written as 2 by 2 pi integration from alpha to pi plus alpha V0 square d omega t whole to the power 1 by 2, which can be rewritten as 1 by pi integration alpha to pi Vm square sine square omega t d omega t whole to the power 1 by 2. We can take Vm square outside divided by pi. Limits from alpha to pi sine square omega t can be substituted as 1 minus cos 2 omega t by 2 d omega t whole to the power 1 by 2, which can be written as Vm by root of 2 pi. Taking Vm square 2 pi outside, we can write Vm by root of 2 pi into integration of 1 will be omega t minus sine 2 omega t by 2. Limits varying from alpha to pi to the power 1 by 2. Now we can substitute the limits. So Vm by root of 2 pi, substituting the limits for omega t, after substituting the limits, we get pi minus alpha. And for sine 2 omega t by 2, substituting the limits, we get sine 2 pi by 2 plus sine 2 omega t by, sine 2 alpha by 2 to the power 1 by 2, which can be rewritten as Vm by root of 2 pi into pi minus alpha plus sine 2 alpha by 2, sine 2 alpha by 2 to the power 1 by 2, because sine 2 pi is 0. So we have seen the single phase semiconverter with R load, and we have drawn the waveforms, and we have derived the average output voltage and RMS output voltage. Thank you.